Let's talk about numbers. For today's lesson, we will discuss how to determine or determining the intercepts, zeros, and asymptotes of the rational functions. We have here the learning competencies. The learner is able to determine the intercept, zeros, asymptotes of rational function. Next, we will define the following. What is a rational function? A rational function is a function of a form f of x is equal to p of x over q of x, where p of x and q of x are polynomial functions. And q of x is not the zero function, since the moment q of x will be equal to 0, the given function will be undefined. And the domain of f of x is all values of x where q of x is not equal to 0. The next we have the zeros of a function. The zeros of a function are the values of x which make the function 0. The real numbered zeros are also x-intercept of the graph of functions. And the y-intercept is a function value when x is equals to 0. So we have here the steps in finding the intercept and 0. In finding the x-intercept and zeros, first is you need to change f of x to y, then let y be equal to 0, then solve for y. And in finding the y-intercept, you need to change f of x to y, then let x be equal to 0, then solve for y. So the difference in finding the x-intercept and y-intercept, in x-intercept, you need to let y be equal to 0, while in the y-intercept, you need to let x be equal to 0. So next here, we have an example to fully understand the step in finding or determining the intercept and zeros. So we have example number 1. f of x is equals to x minus 2 all over x plus 2. So letter A, we want to find the x-intercept and zeros. So we have here the solutions. Change f of x to y. So therefore, from f of x, we have y is equals to x minus 2 all over x plus 2. Then let y be equal to 0. So 0, so this one, which is the y, we let y be equal to 0. So we have 0 is equals to x minus 2 all over x plus 2. So next, we will cross multiply the given expression. So the denominator of 0 here is 1. So 0 times x plus 2 is 0. Any number multiplied by 0 is 0. Then 1 times x minus 2 is just x minus 2. So therefore, we have this. 0 is equals to x minus 2. Again, why 0? Because 0 times x minus 2 is just 0. And 1 times 0 times x plus 2 is 0. Then 1 times x minus 2 is just x minus 2. So next, we have this one. This is by transposition. From negative 2, 0 is equals to x minus 2. So therefore, if we use the transposition property or the additive inverse, this will yield as 2 is equals to x, or this is just x is equals to 2. So again, from negative 2, naging positive 2 by transposition or by the additive inverse. So therefore, the x-intercept is 2, 0. Why 2, 0? This is the x, which is 2, and ry is 0. So therefore, in an ordered pair, the x-intercept, which is 2, 0. 2, since our value the value of x here is 2 and the y here is 0 since we let y be equal to 0. So therefore, the zeros is x is equals to 2. So again, the x-intercept is 2, 0, and the zeros is x is equals to 2. Letter B, we will find the y-intercept. So same process. So we change f of x to y. So again, instead of f of x, we let this one as y. So next, let x be equal to 0. Here in the y-intercept, we let x be equal to 0. So this will be, all x will be 0. So that will be y is equals to 0 minus 2 all over 0 plus 2. And that is y is equals to negative 2 minus 2. Negative 2 rather all over 2. So negative 2 divided by 2, and that is negative 1. So therefore, y is equals to negative 1. So the y-intercept is 0 and negative 1. Why? It is because we let x be equal to 0. So again, this is the x. And this is the y, which is negative 1. So therefore, our x-intercept, our y-intercept is 0 and negative 1 since we let our x be equal to 0 and y be equal, and solve for y, then we yield y as negative 1. So this is the y, the y-intercept rather, 0 and negative 1. Next, we have another example. F of x is equals to x squared all over x minus 3. So again, first we find the x-intercept and zeros. We have here the solutions. Change f of x to y. So therefore, y is equals to x squared all over x minus 3. So again, our f of x, we write that f of x as y. Next, let y be equal to 0. So therefore, the y variable be equal to 0. So we have this one. 0 be equal to x squared all over x minus 2, x minus 3. So cross multiply. So again, the denominator of 0 here is 1. So 0 times x minus 3 is 0. 1 times x squared, that is just x squared. So therefore, 0 is equals to x squared. So in order to eliminate x squared, we will take the square root of the both expression. So therefore, 0 is equals to x, or x equals to 0. So therefore, since we let y be equal to 0 and the result yield us or give us x is equals to 0, the x-intercept is 0, 0, which is, this is the x value, which is 0, and the y value is also 0. So obviously, the x-intercept is on the origin. And the zeros is x is equals to 0, since x here is equals to 0. So next we have the y-intercept. Solutions, again, we change f of x as y. So we have y is equals to x squared all over x minus 3. So let x be equal to 0. So all x will be 0. This will be 0, this will be 0. So that will be y is equals to 0 squared all over 0 all over 3. And that is 0 all over negative 3. 0 times 0 is 0. 0 minus 3 is negative 3. And 0 divided by negative 3 negative 3 will be 0. So therefore, the y-intercept is 0, 0. Again, this is x and this is y. So next, we have number 3. F of x is equals to x plus 1 all over x squared. So first, we need to find the x-intercept and zeros. So we have the solutions. So again, change f of x to y. So y is equals to x plus 1 all over x squared. So y is equals to 0. So 0, so let y rather. So since we let y here be equal to 0, so therefore this will be 0. So 0 be equal to x plus 1 all over x squared. So divided by, cross multiply. So since again the denominator of 0 here is 1, so 0 times x squared, that is x squared. 0 times x squared, that is 0. 1 times x plus 1 is just x plus 1. So therefore, we have this equation. 0 is equals to x plus 1. So by transposition, so again, transposition from positive 1 to here, again, transposition property or additive inverse. So negative 1 is equals to x, or x is equals to negative 1. So therefore, our x-intercept is, so again, our x here, which is negative 1, this is x, and our y, which is 0. So therefore, our x-intercept is negative 1, 0. And the zeros, or the 0 is x is equals to negative 1. Then the y-intercept, we have here the solution. Again, we change we change f of x to y, then copy the original equation. Then let x be equal to 0. So here, so again, this will be 0, this will be 0. So 0 plus 1, that is 1. 0 times 0, that is 0. So y is equals to 1 over 0. And that is undefined. Any number or expression divided by 0 is undefined. So therefore, since y here is undefined, therefore, there is no y-intercept. So no y-intercept. So again, it is because the given here is undefined. So next here, we will proceed to finding the asymptote. So we have the vertical line and the horizontal line. The vertical line x is equals to a is our vertical asymptote of a function f if the graph of f either increases or decreases without bound as the x values approaches a from the right or left. So it only means that it will be the vertical asymptote if it is increases or decreases to that certain line but without touching that line. Then the horizontal line y is equals to b is a horizontal asymptote of the function f if f of x gets closer and closer to b as x increases or decreases without bound. That is, as x approaches positive infinity or x approaches to negative infinity. So we have here how to determine asymptotes, or how to determine the vertical asymptotes and the horizontal asymptotes of a rational function. So we have first is the vertical asymptote. So step 1 is reduce the rational function to lowest term by canceling out the common factors in the numerator and denominator. It is only true if we can cancel some factor from numerator and denominator. Then second, is to find the values a that will make the denominator of the reduced rational function equal to 0. And third is the line x is equals to a is a vertical asymptote. The next is for the horizontal asymptote of a rational function, let n be a degree of the numerator and m be a degree of denominator. If we talk about degree, this is the highest exponent in the numerator and the denominator. The condition given, if n is less than m, the horizontal asymptote is y is equals to 0. If n is equals to m, the horizontal asymptote is y is equals to a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. So next, the last condition is if n is greater than m, there is no horizontal asymptote. So to further understand what do you mean by asymptote and how to determine it, we have here an example. F of x is equals to x minus 2 all over x plus 2. Vertical asymptote solutions. So we have here. So since the given, which is f of x is equals to x minus 2 all over x plus 2 is already in a reduced form, we cannot cancel x minus 2 all over x plus 2. So therefore, we will take the denominator. So again, the instruction in finding the asymptote or the vertical asymptote is to find the 0 of the denominator. So that is x plus 2 is equals to 0. So again, we just copy the denominator, which is x plus 2, and let it be equal to 0. So next, we have x is equals to negative 2. So therefore, why x is equals to negative 2? By transposition. From positive 2, since it is transferred to the other side, that is negative 2, or by additive inverse. So therefore, the vertical asymptote is x is equals to negative 2. So next, we have the horizontal asymptotes. So since n is equals to 1 and m is equals to 1, question here, where did I get 1 for n and 1 for m? So again, that is the exponent of x in the numerator, which is here, the exponent is 1. And the denominator, the exponent also is 1. So then, n is equals to m. So by the first condition, by the second condition, since n is equals to m, what is the coefficient of x here? So obviously 1. So that is 1 divided by 1. So therefore, y is equals to 1. The horizontal asymptote is y is equals to 1, since n and m are equal. So again, I get 1 because the leading coefficient or the leading coefficient of x is 1, and the leading coefficient of the numerator is 1, and the leading coefficient of denominator is 1. The next is number 2. F of x is equals to x squared all over x minus 3. So the vertical asymptote, so again, we cannot reduce this to lowest term. So we just copy x minus 3, then let it be equal to 0. So that is x minus 3 is equals to 0. So again, by transposition or by additive inverse, x is equals to 3. Therefore, the vertical asymptotes is x is equals to 3. Next, we have the horizontal asymptotes. Since n is equals to 2 and m is equals to 1, question is where did I get 2 and 1 for n and m? So again, the exponent of x here is 2. Therefore, the n is 2. And the exponent of the exponent of x in the denominator is 1. So therefore, I get m is equals to 1. So therefore, since n is equals to 2 and m is equals to 1, then n is greater than m. Obviously, 2 is greater than m. So therefore, no horizontal asymptote that is based on the given condition of the horizontal asymptotes. So next, we have number 3. F of x is equals to x plus 1 all over x squared. So the vertical asymptote, so again, just copy the denominator. So we have x squared and let it be equal to 0. So x is equals to 0. So x squared be equal to 0. So therefore, x is equals to 0. Why? If we take the square root of 0 is just 0. So therefore, the vertical asymptote is x is equals to 0. Next, we have the horizontal asymptote. So again, the horizontal asymptote will be n is equals to 1. So again, this is the exponent of x in the numerator is 1. And the exponent of x in the numerator is 2. So therefore, n is equals to 1 and m is equals to 2. So then, so this should be n is less than m. So again, this is n is less than m, not equal to m. So therefore, the horizontal asymptotes based on the given condition of the horizontal asymptotes, y is equals to 0. So next, number 4. F of x is equals to x minus 3 all over x squared minus 4. So what will be the vertical asymptotes? We have the solutions. So here, x over x minus 3 all over x squared over 9 can be reduced to lowest term because the factor of x squared minus 9 is x minus 3 times x plus 3. If you multiply x minus 3 times x plus 3, the result will be x squared minus 9. So we can factor it. So therefore, since we have x minus 3 in the numerator and x minus 3 in the denominator, so we can cancel this one. Okay? So we can cancel x minus 3 from in the numerator and denominator. Therefore, f of x is equals to 1 over x plus 3. So this will be equal to x plus 3 is equals to 0. Why? Again, we need to take the denominator, then equate it to 0. So therefore, x plus 3 is equals to 0. So by transposition or the additive inverse, so we have x is equals to negative 3. So therefore, the vertical asymptotes will be x is equals to negative 3. So again, from positive 3, by transposition or additive inverse, it will be negative 3. X is equal to negative 3. Next, we have the horizontal asymptotes. Since n is equals to 1, y1, since the exponent of the numerator, the exponent of the x in the numerator is 1, so we have n is equals to 1, and m is equals to 2, y2, since the exponent in the denominator of x is 2, therefore, n, this should be less than, okay, again, this should be less than, then n is less than m. So therefore, by the given assumptions of asymptotes, of horizontal asymptotes, The horizontal asymptote will be y is equals to 0. So for your practice, for your exercise, you can practice the following equation or the following function. Determine the intercept, zeros, asymptotes of the rational function. Not only asymptotes, which is the vertical and horizontal asymptotes. You can practice number 1, number 2, number 3, number 4, and number 5. So again, thank you for watching.